Hey guys, and welcome back to UniCodev. Today I'm really excited to show you how to create a multiplayer game in Unity using Firebase. Now, I already created this video before, but it was more of an example demonstration, so there were some security issues. With this new video, everything is gonna be sorted, and we're gonna look at how two players can actually match together. They enter a room, and then they can make turn-based moves, and they can be sent to a backend that can validate them and then put them on Firebase. Now, why am I making a new video with this content? Well, because I actually recently did a talk in Italy, in my country, about this technology, and I actually wanted to bring it to the channel because I thought it would be fun. Anyway, yeah, today we are gonna look at the Unity project and the code, and I also got the presentation right here, so, you know, it's gonna be, for once, it's gonna be a pretty well-structured video, or at least I think. It's probably gonna diverge into something completely different, but let's not worry about that. Anyway, jokes aside, let's get started. Alright, so first of all, why would we use Firebase? Why wouldn't we use any other technology? For example, in Unity, there is Photon Engine, which is really used a lot in multiplayer indie games. It's basically the standard. So why are we using Firebase instead? Well, there are some reasons, okay? If you're making a prototype, and maybe you just want to test the game, or you know it's a game that at the beginning is not going to have many users, it might be cheaper to use Firebase because they have a really more lenient plan, and you can have a lot of users without paying a cent, while with Photon, you on average have to pay that amount for every concurrent user once you go up to 20 concurrent users. Also, if your game you're making is not actually real-time, but it's more of a turn-based game, where you don't worry about timings too much. So an example of a game could be like Yu-Gi-Oh! Master Duel. So that game, you have a timer, but it's like a 300 seconds timer, so you don't care about a 1 or 2 seconds lag. You could use Firebase for that game. And also, as you can see right here, I'm saying 40 cents for million function invocation. We're gonna talk about what these functions actually are, but basically you can think that a function is actually a move, or the player entering the queue for the game. So every time a user does an action, so makes a move, that's one invocation. So you can reach a million invocations pretty fast, but it's still pretty cheap. Anyway, the second reason is that it's actually serverless-ish. So if you use Photon, you also need to have maybe a server somewhere or a plugin that can validate the moves. With Firebase, we're actually not doing that. What we're doing is we are invoking Cloud Functions, which we're gonna see right now, and basically these functions are gonna execute some code. They're basically some endpoints. So Unity calls these endpoints. These endpoints will execute some code, which will validate the move, will put the player in the queue, and these functions will actually communicate to the NoSQL Firebase database, and that is actually what is gonna be storing the information on the database. So the client doesn't communicate with the database directly, and this way everything is going to be secure, and you don't need a server. I mean, we could say the Cloud Function is actually the backend, is the server, but it's not self-hosted. It's just running on a Google machine that just spawns when you invoke the function. So it's really convenient and cheaper. And the third reason is why not? Maybe you want to learn more about Firebase technologies. This is the best way to test all of the capabilities of Firebase, you know, and just experiment. So maybe you're watching this video just for fun, or, you know, because you want to experiment with Cloud Functions, Realtime Database. This tutorial is going to have it all. And also in the description there is the updated code with all of the stuff, so you can already jump into that if you want. Anyway, now that we are done with the boring stuff, let's actually test this out, because, you know, before actually explaining how it works, let's just see if it works. I mean, it's gonna work, but, you know, let's just, you know, test it. So we're gonna run the project both on the Unity editor, which is gonna be my first client, okay, it's gonna be my first player, and then we're gonna also have a build right here. Anyway, I'm just gonna show you, this actually uses Firebase authentication. We're not gonna talk about authentication too much, but basically I can just, you know, use my account and put the password, and I can sign in, and I can also create an account. So as you can see now, I'm signed in as my email, and this other account is signed in as another email. So I can just call this Nico, and this is gonna be my player 1. And now this player is looking for an opponent, and if you see, this is my Firebase database. We're gonna talk about this later, if you don't know anything about NoSQL and databases, but, you know, we're gonna explain it later. This is just a demonstration. As you can see in the branch matchmaking, there is this user, which corresponds to my email, corresponds to my user, and we actually put that this user right here is waiting in queue and his name is Nico. If we actually go to the authentication, we will be able to see all of the users that are signed in into our app, and as you can see there is me, and this UID corresponds to the UID right here. Alright, so there is one player waiting in queue. One player is not enough. Let's spawn another player, and we're gonna call it Nico Chu. And now we're gonna make this guy play. Now there are 2 players waiting in queue, and something magic is gonna happen, a game ID is gonna spawn, and then a new game is gonna be created. So basically inside the queue itself, a new value got added, which is the game ID, and now a new game spawned with the same game ID that got generated. And inside of the game ID there are a bunch of infos. So at example, who is playing the game, so there are 2 players, the name of the players, the user ID of the players, the game ID at example, and also there is a value showing whose turn it is. It's a turn-based game, so we need this value. Now, all of this information got automatically generated by Cloud Functions. They're actually functions that can run on the Google server, and they can be called both via endpoint, so just by doing a request to a certain endpoint, or when a branch on the database updates. So if there is a new branch inside the matchmaking, I can set it up so a Cloud Function runs and generates the game data. But now if we go back into the client, as you can see, the client knows that this data was generated, and this is also really important. Once we actually generate the data, how does the user know that, the game is ready? Well, we're gonna see it later, but the way it knows is thanks to this game ID. So the client is gonna be listening for this value, and once this value is filled in, then they know that there is a game right here, and they're gonna go look for it. And now we just gotta ready up. So if we do ready, as you can see, inside our game, a new value is gonna appear, which is all of the players that are ready, and right now this player is ready, and now if this player is ready too, we're gonna be ready to start the game. Now the game is just an example, so it's just a turn game, so I can actually move around this square, and I can move one turn at a time. So it seems really slow, so as you can see the move still hasn't processed, but it's actually not slow, it can go very fast, it's just that Firebase scales on the amount of users you have. So right now, the last time I tested this application was 1 month ago, so naturally Firebase is like, I don't care, I don't need to execute requests really fast. But as you can see, the more moves I will make, the faster it will work. And as you can see, it's pretty much, it's not real time, there is like 1 second delay, but the more users there are, the more it's gonna scale. So the delay is gonna be, much less. But honestly, you can expect a 1 second delay at any time, and if you don't care about these delays in your turn-based game, you can use Firebase anywhere, and you can use this setup. Maybe if the game is something like chess and you're playing Hyper Bullet, you will need a faster delay, or people are gonna be mad. But as I said, if it's a game like, I don't know, Yu-Gi-Oh! Or any card-based game, you don't need to worry about a timer, so you can use Firebase just fine. You definitely cannot use this for a first-person shooter game. I actually tried it in the past, and no, it was fun, but yeah, definitely don't use that. Anyway, as you can see, every time I make a move, the database inside the game is gonna add the move to my player info. So as you can see, these are all of the moves that I make, and then the client is gonna be listening for the moves and applying them. So this is the main gist on how it works, and as you can see, if I leave the game and the other player leaves, it's actually not gonna clean up the game. It's gonna clean up the queue, but the game is not gonna clean up. So you can set it up so if a player leaves, it can automatically remove the game, maybe assign a winner, but there's a lot of stuff that you can set up on your own once, you understand this logic. So this is just an example, and this is basically what it can do. So now we deleted all of the data, and we can go back in showing how it actually works. So right here, I actually had a fallback of a demonstration where I just showed a video, which is not working. But, we don't need the video because we have the live... Okay, there you go. We have the live feed because luckily nothing goes wrong when I'm recording, in a room, rather than when I'm doing a talk with a bunch of people and, my computer just shut down in the middle of the talk. So yeah, that was pretty awkward, but it worked out in the end. Anyway, let's continue. No, okay, no. Alright, so before jumping into the code, I want to show you how the actual communication between the client and the database works, because it's really important to know this setup so that, our application can be secure. Now, the client will talk to 3 different Firebase services. The first service is the authentication service. So the client will just authenticate with email and password in this case. Using the Firebase authentication service, it will create a user and it will sign in as a user, and this will give it a user ID, which is a unique identifier for the user, and an ID token, which is basically a key that tells tells Firebase this request is authenticated. You are signed in as this user. So every other request that we do to the other two services are all gonna be authenticated using the authentication service. And we're gonna see how it works later. Then the other service that we're gonna use is the Firebase database. But this is really important. We are only reading the database. The database is actually locked. There is no writing on the database. You can only read on the database. So if a client tries to do a post request to the real-time database endpoint, they're gonna get blocked because they're not supposed to write any data. They're just supposed to read and listen for updates in the data. An example, a new move being made, or getting matched with another player. In order to actually write stuff on the database, you have to go through the Cloud Function service. You're gonna do a request to the Cloud Function, which is gonna basically spawn a machine executing some JavaScript or TypeScript code, and that code is gonna validate the information the client gave it, and it's gonna then write to the database. And as soon as this Cloud Function writes to the database, the client is gonna get the response in form of a listener. So the client will be listening on some data, and it will be sending the request to the Cloud Function. The Cloud Function will write to the database, and now since the client is listening to that database, it is gonna get the new data. So when I said it's serverless-ish, this is what I meant. There is a server side, which is the Cloud Function and which is writing on the database, and there is a client side, which is the client listening through the database. So there is a client and a server communicating, but they are communicating through the database. Now this is really beautiful and all, but for which platforms does this run? Because the Firebase Unity SDK is only supported for Android and iOS. But fear not, because this system can potentially work on all platforms. Now it will work without any problems on Android and iOS. For standalone versions, so Windows, Mac and Linux, you can actually still use the Firebase Unity SDK, which will allow you to listen for a value to the database, invoke a Cloud Function and authenticate, but in the documentation it shows that this approach is still in beta. So the way you actually are supposed to do this is via the Firebase REST API. Now the Firebase REST API has all of the functions that the Firebase SDK has, so you will be able to do this with APIs as well. The only thing that is a little bit different on REST APIs is listening for a certain data, because you would have to use streaming APIs, but it's doable and you can set it up pretty quickly. I actually have some videos on how this is done. But yeah, also if you're doing this just to prototype, you can use the Firebase Unity SDK for standalone as well, and you're not gonna have any problems. And frankly, I used the SDK in production as well and didn't have any problems, so... But it's been in beta for at least 5 years, so I have no idea at this point. If you are crazy and you actually want to do a WebGL application, there is also a way to make this work. You can still use REST APIs, like you would do for standalone. You can definitely not use the Unity SDK, but you can also use the JavaScript SDK. So you can inject some JavaScript code, which is the JavaScript SDK, in your WebGL build. And I actually have a tutorial on how to do this and a project, so you can check that out. But again, you can still use the REST API endpoints if it's easier. Alright, so next up, let's actually go and take a look at how the project is structured. Now, I talked about how I structured my projects in the past in other videos, but every time I'm working on a project, I try to subdivide the classes in different components that do different things. I usually come up with a division of 3 different types of classes, okay? There is the APIs. Basically, the APIs are supposed to be static classes, so that there is just one instance for every class, they're static, and they are supposed to communicate with services that are outside of the application. So, for example, they will communicate with the Cloud Function Firebase API, the Authentication API, the Database API, or they will just be some utilities that are useful, like the serializing and serializing JSON. So these APIs are basically the bare bone of the application, and they provide utility and helpful methods that the managers and the handlers can use. So for example, the Auth API is going to provide a method which is going to be sign in, and you give it an email and a password, and what to do after you actually signed in, and that API is going to do that. Now instead, the handlers are on the complete opposite part of the spectrum. So instead of being the bare bone, so the lower part of the app, they're going to be the higher level of the application. They're going to be communicating directly with the UI. So, for example, in the game scene handler, which is the scene where you can actually move the player, let me pull it up right here, you can see that the UI is pretty simple. There is just one button that makes you leave the game. Well, the handler is gonna actually implement this button. So in the game scene handler, there is gonna be a function that will be invoked when you click the leave button. So the handlers are basically a way to translate the user input into invocations on functions. And there should be one handler for every scene at least. And then maybe if you have a specific object like a player that can move, you can do a handler for every instance of that player. So in my case, in the scene, there will be 2 player handlers underneath every player object. And now these handlers are gonna communicate with the managers, and the managers are what actually contain the logic of the code. So the UI, those are requests to the handlers communicate to the manager will do all of the logic and will be helped by the APIs to do outsider requests. Now in this project, the way the managers are structured is using a singleton. So the main manager is one instance that is present in the entire application, and then from this main manager you can call all of the other managers. But you could set this up in a different way that maybe is more convenient for you. You could, I don't know, do like dependency injections and stuff like that to have multiple managers. But you know, this is the way I set it up for simplicity. But I think it's really important to know how the project is structured for this case, because we are gonna see for Cloud Function calls, we are gonna start at the lower level at the API, and we're gonna move on to the manager and then to the handler. So in order to understand how the code is being executed and what it's doing, it's really important to have this structure in mind. So this is an example of an API, it's just the authentication API. As you can see, you can sign up and sign in. We're gonna see it better later. An example of an handler is the game scene handler. So as you can see in this scene, there is just the leave button, which is gonna just change the scene. And then when this scene is actually destroyed, it's gonna invoke the game manager. So when the scene is changed, it's gonna invoke the game manager and it's gonna tell the game manager to leave the game. So if you see inside the game manager, inside this leave game, we are actually gonna invoke a database API to stop listening for moves because the game is over. So as you can see, this is how it goes: handler, manager, API. And we will see this later, but when we make a move, we are actually listening for a move thanks to the database API. The database API is going to return a response, the manager is going to parse this response, and is going to give this response to the handler. And the player handler is actually going to modify the UI and execute the move. So as you can see, it will move the actual player by changing its transform position. Now naturally the code is a little bit messy, but as long as you have this structure in mind, you're good. Alright, so now let's start looking at the code. Now I'm gonna look at the code through the slides, because I actually simplified a little bit. So on the GitHub project, it's gonna be a little bit different. There are gonna be some extra lines here and there, but the main gist of it is the same. Alright, so the first thing we want to look at is how the players actually make a move. So the players are already in the game has already been created, and all we want to do is press a button and send the request to make a move to the Cloud Function, and we want to see how it works. So we're gonna actually start at the very end. So this is the Functions API, which makes you call different Cloud Functions. Alright, so we're gonna use the Firebase SDK to call the Cloud Function to make a move. As you can see, we're gonna invoke call functions with the name of the function and the data. And as you can see, the data is just a move object, which is just gonna be an array of two values, the X component and the Y component of the move. So this call function is actually pretty agnostic, so it will call any function with any data, and it will actually use the functions from Firebase SDK to do an HTTP request and call it. And as you can see, this function right here is asynchronous, so it will wait for the result of the Cloud Function before continuing to execute. So as you can see, inside this code right here, there is gonna be some code that will run once the request is completed, and we're gonna check if there were any errors, and if there were any errors, we are gonna send back, instead of sending back the data, we are gonna send back an error. So this request response right here that you see is a dynamic object that can either be an error or it can be some data. So if there have been any errors, we're gonna return the errors, and also if the data is not in the right format, so it's not an array, we are gonna also return an error. But if there haven't been any errors, then we're just gonna return the data. And now who are we returning this data to? We are returning this data to the manager, because remember, the managers invoke the APIs. So the game manager communicated with this API to send the move, and now this API is gonna tell the manager that the request was successful. So the game manager code is pretty easy, because in this case we actually don't need to manipulate the data, we're just sending the move and getting it back. So all we need to do is actually tell the handler everything is fine, just execute the move. So we are not doing any extra code in the manager, we are just, awaiting for this function to be completed, and that's it. Now this game manager function is actually being invoked from the player handler. So as you can see, every single tick, we are checking if the player has made a move. We are first checking if it's their turn, and we are checking if the player has made a move, so if they are hit any of their keys, and if they made a move, then we are gonna actually invoke this function. But now there is something really important about this. We are not gonna invoke it normally, but we're gonna invoke it as a coroutine. And you may say, well, Nico, why are we doing that? Well, because as you can see, this function right here is asynchronous, so it's not running on the main thread. So we need a way to actually, divert our code execution to a different thread. Because we need to wait for this response. We need to wait for the function to actually be called and for it to return a response. But this update function is running every single tick, so if I didn't write asynchronous code right here, we would be stopping the main thread, which would be really bad. In Unity C#, there is a really cool solution to this, which is called coroutines. Coroutines basically allow you to execute code on a different thread, but you actually don't need to worry about threads and their lifetime. It handles everything automatically for you. Now, I did a video on coroutines in the past, so you can go check that out, but I'm gonna explain how they work really briefly. Anyway, once the player has actually made a move, we are gonna set the move, and we're gonna, just invoke this coroutine function right here. So now, these are how coroutines work. Basically, you can invoke a coroutine by doing start coroutine, hello coroutine, and inside of it, you can actually set some delays, so you can await for a certain function to be called, just like asynchronous functions, or you can just wait for 5 seconds, and it's gonna run this code after 5 seconds. Another cool behavior of the coroutines is that they are attached to the object that invoked them. So this player handler actually is handling this coroutine. So if this player dies, meaning, they get killed, or we just move out of the scene so this object dies, the coroutine will actually stop executing. And this could be a really cool thing, or a really bad thing. So if you don't want this to happen, you should probably invoke the coroutine on an object that you know is not gonna despawn. So it could be an object with a do not destroy unload flag, or a manager if you want. But in my case, I don't care about that, so I'm just invoking the coroutine on the player handler. Alright, so what does this coroutine do? This coroutine will basically invoke the game manager, and as you can see, this is the singleton I was talking about. The main manager as a reference to every single manager, and from it, we're actually getting to the game manager class. We are gonna invoke the sendMove function, and then using this syntax right here, we are gonna wait until it's done. And now this wait for task is actually a helper method I implemented myself. It's in the main manager, but it's basically, some sugar syntax for this. So you can just do wait until the task value is completed. So it will basically wait until this boolean is true, and this boolean is true only when the request is done, because the task is completed. So this is a quick way to convert from coroutines to asynchronous code. So as you can see, we're gonna await for this asynchronous code to be completed, and once it's completed, we're actually gonna get back its response. And if you guys remember, the response was a request response with some data or an error. And as you can see, when we go through the manager, this request response actually gets implicitly casted to a request state. Basically, the request state only cares about if there has been a mistake or there has been an error. It will actually return no data. So it will tell you there has been an error, this is the error, or it's gonna be empty. So this is the difference between the request response and the request state. Whoops. So just to show you, this is the request state. So it's basically a boolean telling you if there has been an error or not. And if there has been an error, it will give you the error. While the request response actually inherits from the request state, but it also has some generic data that, you could get. Alright, and now that that is explained as well, as you can see, we are back here, and once we actually sent the move, if there have been any problems, we are gonna, just print the problems. In your case, you could show an error on screen or anything. This is just an example, so we're just gonna print the error. And now there is something really important here that is going on under the hoods, and I'm gonna show you right now. So as you can see, as soon as you make a move, this flag gets set to false. So as soon as you do the request, you're not going to be able to make another move while the request is processing. So you will not be able to spam your left key and make a lot of moves while they are not being processed yet. So this flag right here is making sure that you can only do one move at a time. So as soon as you do the request, it's gonna automatically not be your turn anymore, but there is something important. If something goes wrong, so the request didn't actually go through, the function didn't process it, instead of actually soft locking the game, we are gonna give you another chance to make another move. So it's gonna be your turn again, and the user will be able to actually try making another move. So maybe if their internet connection dropped out in the middle of the game, and they are back, they do the request and the request fails, when they are back online, they will actually be able to do the request again, thanks to this flag. This is something you will see for every request that we are gonna look at, so it's really important to have this safe prevention when something goes wrong, so to have a fallback. And have a way not to completely soft lock the game. And it's also really important to have this flag right here so that the user cannot just spam a request over and over by clicking a button. That is really important. And alright, this is how you actually send a move, and believe it or not, we went through a lot of how the code works because all of the other requests are actually pretty similar. Now let's do the opposite, let's try to listen for a move. So we're waiting until another player makes a move, and once they actually made that move, we need to actually receive that data and update that specific player handler to make that move. Now this code looks complicated, but it's just a bunch of error handling, honestly. All you need to care about is that this function right here, from the database API, will be able to tell you if a certain child was added to a list on the database. So as you can see, if we go to our database, oh, it's empty, never mind. But okay, if we write some data, like at example games, and we add our game ID, so this is gonna be, I don't know, an ID of a game, and we're gonna have moves at example, and inside we're gonna have a move, so this is move 1, and it's gonna have, I don't know, it's gonna have two values like this. This code right here will be able to detect if a new branch was added into this specific node. So if I add a new move, this code right here will be able to detect it, and this onChild added callback will run. And this onChild added is actually a callback that is defined as a function parameter. So basically when we are invoking this function, we're also telling it what to do when a new child got added. We're also storing this listener so that in the future we can actually stop listening for this specific instance instead of stop listening for all of the instances. So this is why the code is much more convoluted than it's supposed to. But okay, let's not worry about that. So this game manager will be able to invoke the listen for child, and as you can see, one of the arguments is going to be the path, and the path that we want to listen to is the current game, the player ID, and the moves that this player is doing. So we're gonna check if that player made a new move. And the other argument of the function is gonna be the code to execute when the move is gonna be made. And now Firebase Realtime Database is a JSON-based database, so it will return us the response in JSON. So this manager right here is actually parsing the response and making it pretty, so it will turn it into a move. And then once the response is actually pretty, so it's not some JSON, but it's a move object, it's gonna send it upwards. So it's gonna send it onto this callback, and this callback is defined as a parameter of the function. So the handler that is invoking this manager is actually gonna take care of implementing that code. So the API listens for the request, the manager processes the request and makes it pretty, the handler will actually move the player. And we're gonna see it right now. The handler we also have some code for listening, stop listening to moves. And this is why we need to have the reference to the database thing, to the database listener. So right here, as you can see, this function is actually returning this abomination right here, which is the reference. And we're gonna use this reference to actually stop listening for moves at some point. But it's not important. Anyway, keep in mind this handler, it has one instance for every single player that is in the game. So this code is gonna be executed as soon as a player spawns. So in our case, as soon as the players get to the game scene and their instances spawn. So as soon as this starts, we are gonna invoke the game manager and we're gonna tell them to listen for moves. And when listen for moves for this specific player, remember this code is gonna be run for every player because there is an instance of this class on every player object. And then we're gonna tell it, once there is actually a new move, invoke this function right here. And if there is any mistake, just log the mistake. Right here you could put any other function that handles the mistake, maybe showing the error on screen, maybe making the player leave, I don't know, anything. This function right here though is what's important. This function is going to be invoked when a new move is made. And what does this function do? Well, it's really simple. It will just change the position of the player. So all of this complicated code right here that does all of the stuff, all of this game manager that is translating the JSON into a move, all of this is tucked under the carpet, and the actual beautiful code you see is these 3 lines right here. Which makes sense. Listen for a move. When you receive the move, move the player. It's really simple. So this is why structuring the project this way is really important to, have a mental image of what is going on. And, if you want to change something, so maybe when the player makes a move, their color changes, or I don't know, they move 2 squares instead of 1 square, you just need to change this line. You just need to look at the handler. You don't need to care about the managers. The managers are guaranteed to return you a move or an error. So you only need to care about the data that you're getting back. You don't need to care about any of the logic beneath it. Alright, and next up I want to talk about user authentication, because yes, we kind of said that we are doing requests to the cloud function and to the database, and we are pretending to say, okay, the database knows that this is me, this is my account making the request. I cannot make the moves on behalf of another player, or on behalf of a player that is not even in my game. So how am I actually authenticating my requests? Well, if you use the Firebase SDK, it's actually really simple to authenticate your requests. Because if you use the Firebase authentication service and you sign in or sign up, automatically all of the other services will be authenticated, so you don't have to do anything. If you use REST APIs, it's gonna be a little bit more difficult, but it's possible. There are a lot of libraries that do it, and I have a tutorial on authentication with REST APIs if you guys are interested. Anyway, once the game starts, we are gonna start on the loading scene, and the loading scene is actually gonna check if you are authenticated or not. And the checking if you're authenticated or not is just a request to the API. It's basically checking if you have a token or not. And if you are authenticated, you are gonna go to the menu scene. If you're not authenticated, you're gonna go to the login scene. And we're gonna look at the login scene now. So this is the handler for the login scene. So as you can see, it's gonna have the sign up button, and below there is also the sign in button. I probably didn't show it, yeah, because it's literally the same. But yeah, the sign up button is just gonna do a request to the API. You can see we're not going through the manager right now, just because I got lazy, but also because the manager is not doing any additional operation. So we are communicating, the handler is communicating directly to the API. If you want to be consistent, you could actually put a manager in the middle, but in this case I didn't. So the handler is directly communicating with the API, is signing up using the email and password input fields, and is gonna await for this being done, always using the coroutine. And then, if something went wrong, it's gonna, I don't know, it's gonna show an error on screen, and if everything went well, we're actually gonna go to the menu scene. So it's pretty straightforward, and as you can see, this is how the application works. We have this loading scene, we go to the menu scene, if we are authenticated. If we are not authenticated, we log in first, and then we go to the menu. In the menu, you can actually click the sign out button, so you can go back to the login, and then you can go back to the menu, and when you're actually ready, you can go into a game. So this is basically the setup of how the scene flow works. Probably should have put this slide before, but it's whatever. Alright, so how are we actually authenticating the user? Well, with the Firebase SDK, it's really trivial. You just have to do you just have to invoke this function, give it the email and password, and you can await for this being done. You can check if there have been problems and stuff like that, but if there haven't been any problems, you actually don't need to return anything, because the Firebase SDK now is authenticated, and every other request that you do, so like an example, let's go, this request right here, to listen for this child, this is automatically authenticated if you signed in. And since we signed in at the beginning of the app, we don't need to worry about an authentication anymore. So it's pretty straightforward. Alright, and this is it. This is it for the client code. But there is some part of the code that I didn't show. It's the backend. It's the JavaScript stuff. Every time we make a request to a certain endpoint, a cloud function, we're actually executing some custom code on a Google machine. And this code is going to post data on the database, it's going to validate data, it's going to do some logic, and now we're going to be looking at that logic to show you how that works. So how do you actually write this JavaScript code, and how do you tell Firebase to execute it on demand? Well, it's actually extremely easy. I did a video on this too, but basically all you need to do is go into an empty folder, do Firebase init in a terminal. You need to install Firebase tools and npm, but this basically brings you the Firebase command. Then you can write your code. It's gonna basically tell you to log in, it's gonna tell you the project you want to write your code in, and then it's gonna return you an index.javascript file in the folder you just created, and you will be able to modify this file to write some code. And once you have written the code, then you can just do Firebase deploy, and this code is gonna be automatically, go on your Firebase project, and it's gonna be served and invoked when a user requests the function on a certain endpoint, or when, a certain node changes on the database. We will see this now. So after all of this is done, you can just profit. Alright, and this is how the backend looks like. So these are all of the functions that we are invoking. We are invoking one for joining and leaving a queue. Then there is the really important function that we're gonna see at the end, which is the matchmaker function, which is actually the one we are all here about. So the logic that will actually take two players and pair them together, which is also a really interesting logic in it of itself. And then we have two other functions which are basically gonna be invoked when a player wants to be ready, and also when the player makes a move. So at the beginning of this video, when we showed the functions API invoking the make move function, this code is actually gonna be what is invoked. And also there is a missing parenthesis here, and it's gonna be triggering me quite a lot. So let's just move to the next slide. I'm not gonna show you all of the functions because are really similar. But just to show you how the backend works, this is the join queue function. So other than the data that the user sends us, in this case, if you remember, the user was sending us their name when they joined the queue. But other than sending this data, we actually get some context data, which is basically what I was talking about before, the authentication data. We already know if this user is authenticated or not. So all we need to do is check if, they are authenticated. So basically this assert out is checking if the auth parameter is not null, and then we can get their player ID this way. And we know that this ID is them because they are authenticated at that user. So we are 100% sure that this is legit. So basically we're gonna get their name, we're gonna get their ID, and we're gonna post some data on the matchmaking branch. And as you can see, we're gonna post this data that we saw at the beginning of the video. Now, if everything went well, we're gonna return a successful request with no data being returned. If there had been a problem, we're gonna return a failed request with the error. So yeah, this is everything. This is the code. It's pretty neat. And now the successful request and failed request are basically these objects right here. They're basically on pair with the request response object that, I was talking about before. So this one. So it's just gonna have is faulted and an error, and the same thing is right here. Alright, and we have the same exact code for leaving the queue. The only thing that changes is instead of set right here, so instead of setting a value to the database, on the same node, we're gonna remove that key. So it's the same exact thing. Alright, and now let's move on to the interesting bit, which is the matchmaker function. Now this function is a bit long, so I subdivided it in a bunch of parts in the different slides. So this is not the entire function, there is more. So the first part of this function is actually taking two players and pairing them up. So first of all, I'm generating a game ID, and this is basically a random set of string. You can also check if this game ID is already present before, so you can do a request to the database and see if there is a game with the same ID, in case you're unlucky. But I'm not doing that. You could do that if you want in this implementation. Also, another thing to note is that this function is not being invoked like the other functions. So as you can see, these functions right here are all being invoked on an endpoint call, so on call. This function right here, though, is not invoked when you communicate with an endpoint, but it's invoked when a certain reference of the database changes. So this onCreate matchmaker player ID is basically saying as soon as there is a new node inside the matchmaking branch, so a new player, so a new player got added to the queue, as soon as this operation happened, then invoke this function. Alright, so thanks to this function, we also have the player ID, which is basically the newest player that got added to the queue. So we already have one player, we just need to find the second player. So we're gonna go through all of the players in the queue, and we are gonna check if we find a valid second player. So we're gonna iterate over every single player, and we're gonna try to find a player that is not already in a game. So if you guys remember, when you enter a game, your game ID value is gonna fill in. So we're gonna check for a player that is not already in a game, and also a player that is different from the one that, you know, just got added in. Right here you could add some more conditions like matchmaking, I don't know, points, like the player need to have the same amount of rating points in order to be paired and stuff like that. But if all of these conditions are met, then we're gonna set up a second player. And now after this operation, if the second player was not found, then we just need to wait. So we're just gonna return, and you know, this function is gonna be invoked again once we have, you know, a new player, and so the matchmaking is gonna, you know, try to pair two players again. So okay, now we have the two players that we want to pair. Now we just need to pair them up, right? How do we do this? Now there are two ways to do this. There is the dumb way and there is the smart way. The dumb way is just creating the game, like without doing any checks. The smart way is using transactions. Now, why do we need to use transactions and what are transactions? Basically, if there are a lot of players in our game, this function could actually execute multiple times and pair up players that are already have been paired up. You might say, Nico, the first part of this code is actually checking if a player is already paired up. So how could this mess up? Well, if this code executes, we get the player, and then by the time we are posting actually this data, this function executes again on a different pair of players. We could get inconsistent data. So maybe a player could be paired up with two games, or a player that is being paired up left the queue. So we could get a lot of different weird scenarios that are gonna be really hard to handle. Now, luckily, Firebase makes this easy for us with transaction. So when you do a transaction, you are basically assuming the data on this branch is not gonna change. So when I'm doing this transaction, I'm basically saying the matchmaking branch, while I'm doing this operation, is gonna stay frozen, it's not gonna change. So the state of this branch is gonna be right here. So I will know the state of the branch when I'm doing the transaction, and I will be able to write data into it and then post it. Now, when I post the data, if the state of matchmaking has changed, meaning a new player got added to the queue, or that player got paired up with another player, then I'm gonna abort this transaction, I'm gonna do it again. So this code is only going to execute and actually post data to the database if the state of matchmaking remained the same as the one I got right here, as the one we can see right here. So this way I can make sure, with these checks, that the players that I'm getting are actually already, are not in a game and they are still in the queue. So this is what I'm checking. I'm checking if the player 1 is in a queue, and I'm checking if the player 2 is in the queue, and they are not paired up to any games. If their state changed, then we should return matchmaking, so we are not gonna do anything. Right here, instead of not doing anything, maybe you could call this entire function again, so attempt again to pair two different players, but in this case, I'm not gonna do anything, so I'm just gonna stop. If instead the data is not corrupted, so everything went well, I'm gonna actually go into each node, so the player nodes, and I'm gonna add the game ID key. So this is what we saw at the beginning of the video, where as soon as the two players got paired up, the game ID got filled in. And once the game ID is filled in and this function actually executed, we are gonna go into this then statement. So this then statement, the code right here, is only gonna execute not only if we paired the two players, but also if we were able to create a game out of those two players, and we are 100% sure there have been no conflicts. So once that is done, oh, this just shows how the transactions work, by the way. So as you can see, this is the code to actually, this is from the documentation, this is the code to actually star a post on, I don't know, on Facebook have not stars, they are likes. So yeah, put like on a post on Facebook, for example. So we're gonna do a transaction, and we're gonna check if the post exists, naturally. Now, if we already have starred the post, the star count should decrease, and we are no longer starring the post. Else, if we haven't starred the post, or the post doesn't contain any stars, we are gonna add our count in. This way, even if the user spams the star button, the transactions are gonna execute in order and in the right state, so that the like feature will work. And this is also if two people put like at the same thing at the same time, this is gonna handle that. Because if anything goes wrong, this transaction is gonna fail, and this code will be executed again with the new post state. So this is magic, and it works. Alright, as you can see, this is what happens when we actually pair the two players, so the game ID gets added into their matchmaking data. And finally, the last thing we need to do, so the code that we have to execute after all of this is done, is actually creating the game, and it's just posting a lot of information that we might need about the game, like the game ID, the player info, all of that stuff. So it's basically this information right here, and that we saw before. It's just dumping a lot of data on us that the client will probably need, so not really much to say about this. And finally, let's go quickly at the other two functions that we have. Ready Up is pretty self-explanatory. Basically, when the player clicks the Ready Up button, the handler is going to be called, which is going to call the manager calls the API, which calls this function right here on the cloud, and it's basically always going to do the same checks if the user is authenticated, but now it's also going to do a different check. It's going to check if the player that is readying up is actually already in a game. So we are checking if in the matchmaking field this player has a game ID set, and if this game ID is, an actual game. And we are gonna return this game ID, and we're gonna use it to actually ready up in this game. So we're gonna get the game ID from the queue, and then we are gonna make the player ready up in this game. So as you can see in the data, the input of this function, we actually don't specify the game ID. I'm just telling the cloud function to ready me up, but the cloud function actually doesn't receive the game. And this way it's 100% secure, like the player cannot ready up in someone else's game or in a made up game. It's actually gonna check the player game first, if it exists, and then it's gonna do the ready up. And as you can see, this is exactly what happens. And finally, this is the code for making a move. It's the exact same thing as ready up, except that now as an input we get the vector of the moves, and we also have this helpful method which is gonna assert that the move is valid, and you're not moving two squares, or you're moving, I don't know, diagonally or something. So this is just the code to check if the move is valid, but this code could be anything in your application, so you could change this to anything, and you would just have the same system that works, but with a different move. You could change this to the rules of the game of chess, for example, and it will be the exact same system, because we are always posting some JSON data, some text, in the end. So you could just make the move object something different, change this function, and everything else will work the same. And finally, once the checks are done, we're gonna again check for the game ID, and we're gonna post a move on that game ID. Another important thing is that when we're posting the move, we actually don't want to, we don't want to set it underneath player moves. We actually want to set it underneath player moves, then generate a random key, a unique key, and then add that move so that it gets added in as a child. So as you can see, when we create a new move, there is this new key that gets randomly generated. Well, probably not randomly generated, but it's a unique ID of this branch. So we want to generate this string of characters where we can place our move inside, so that, a new children gets added to the moves object rather than replacing the entire moves object. So in order to do this, we use the push function. If you do this push function right here, it basically means instead of setting the data in the moves branch, so right here, set the data in the moves branch on a unique key underneath the moves branch. So we go to the moves reference and we do push to generate this key, and then we're gonna set the data under that key, and the data is the move that we're making. And after everything is done, we are just gonna return a successful request. Alright, and this is it. I showed the backend, I showed the client side, but now there is one more thing to show, and that is Firebase database rules. Because we have been talking about security a lot, and if we go to actual Firebase, as you can see, I can read all of the data because I'm on the console, so I'm actually an admin. I can read all of the data of the database and I can write to it. But as I said before, the users should not be able to write any data, but also they should be limited in the data they can read. They should only be able to read the data related to their own queue and also related to their own games. They shouldn't be able to read the state of another player's game if they are not in it. So thanks to Firebase, and I made a bigger, more broad tutorial just on Firebase database rules if you want to check that out. But just thanks to Firebase, we can create some rules in a JavaScript format to show Firebase which requests we should negate and which requests we should approve. Now, the first thing to note is that there are no write rules, so there is no way that a user can write on the entire database. And then in the database, we have two main nodes. We have the matchmaking, which is the queue, and we have the games node. So we are writing a read rule for both of these nodes. So the read is only going to be allowed under certain conditions. If you are in the matchmaking node, then you need to be authenticated as that user ID if you want to read the data underneath that user ID. What does this mean? I can show you right now. So if I create a new node, which is matchmaking, at example, and then we create user ID 1, at example, this is going to be the random, not random, but it's going to be the jumble of characters that makes the user ID. So inside of here, there is some data, okay, which is going to be basically the game ID. So as you can see, this data right here, I can only access it if I'm signed in as user ID 1. And we can actually test this. So as you can see, the rules are right here. We can actually use the rules playground to test this. So I'm going to try to do a GET request to matchmaking and then user ID 1. And I'm going to run the request. And as you can see, it's going to be denied. If I try to authenticate and I run it, it's going to still be denied because I'm authenticated, but not as a certain user ID. If I change the user ID to exactly what I'm trying to get, so user ID 1, only then I will be able to be allowed. So this is how the matchmaking rules work, and then we have a much more strict rule for the games, because if you want to read information about a game, we need to make sure that you are actually in that game. So what this code is doing is basically getting the entire matchmaking branch, so it's getting the entire database, but I mean it's not actually getting the database because this code is executed on Firebase itself, so it already has all of this information. Like, it's not expensive to do these calls, and I read also on the documentation these are free. So you can go to the root of the database, okay, go to the matchmaking node, and then we are checking if inside the user ID that the user is authenticated with, if the game ID value is equal to game. Only if that value is equal to the name of the thing we're trying to read, only then you should be able to read it. And we can test it right now. So we can try reading game 1, for example, and as you can see, it's not gonna work. I mean, okay, sorry, there you go. It's not gonna work because this fails. But if we actually go into data, and inside the user ID 1, we add a game ID field with the game 1 in it, if now we go to the rules and we do the exact same request, so we need to be authenticated with user ID 1, and the location needs to be games game 1, then we will be able to read correctly, only because the data was there. So this way, only requests that are legit can be done to the database, nobody can steal our information, and most of all, nobody can write anywhere. That's something you can never do. Because the Cloud function takes care of writing, not the client. And the Cloud function needs to take care of writing, because this way they can validate the data. Alright, so this is it, this is the video. We've seen how to create, some good project structure, or at least the structure that I use for my projects to keep everything organized. We've seen how to create asynchronous code in Unity, or how to go from synchronous main threaded code to asynchronous code in Unity using coroutines. We also looked at how to listen for certain events in the database using the database API and the Firebase SDK. And then we've also seen how to actually write some JavaScript or TypeScript code to actually execute some functions in the cloud without a server, so that's pretty fun. And then finally, we learned how to use transactions on that backend code to actually assure that the data is, not corrupt, or that we don't corrupt the data, we don't get race conditions when we modify it. And then finally, we know now how to secure our database with cool and secure Firebase rules. And I know this video is a little bit all over the place, like it's not like a regular tutorial where we only talk about one thing, it's more showing you what you can do with Firebase and the main, caveats and interesting things about creating a multiplayer game, the main things you have to worry about, and the main tricks that you can use in order to actually accomplish this. But this is what I wanted to show you, and I hope you guys really enjoyed this video. And I think this is it. Yeah, I mean, if you have any questions, you can write them in the comments. This is just from the talk, so wasn't supposed to be here. But yeah, thank you ever so much for watching. The slides are gonna be in the description if you need them for whatever reason, but also the code, the full code is gonna be on my GitHub. It's all gonna be in the description so you can go check it out. Let me know if you enjoy this style of content. I'm gonna try to create more, and this was really amazing to make. Thank you ever so much for watching this video till the very end. You are the best. Leave a like if you enjoyed, and I'm gonna see you guys in the next video. See ya!